Malcolm Training Tutorials. Analysis Topics. Pivoting between data sources. In this video, you'll learn about Malcolm's data sources and how to pivot between them. First, we'll provide an overview of Malcolm's data sources and field types. Then, we'll demonstrate how to apply this knowledge to pivot between data sources in a practical scenario.
1. Overview of Malcolm data sources and field types. Malcolm processes network traffic data from live capture sources and uploaded packet capture PCAP files. Once network metadata logs are generated and forwarded to Malcolm, it normalizes and correlates the data to ensure consistent representation across network protocols. Let's focus on the second column of this data pipeline. Malcolm has three data sources: Zeek, Suricata, and Arkime. Malcolm harnesses the power of these three different open-source tools to look at the network traffic in different ways. These three tools examine the same network traffic data, leading to some overlap in information such as protocol and source and destination IP addresses and port numbers. Despite the overlap, each tool has unique strengths and offers distinct insights into the network traffic. For example, Zeek is an extensible open-source passive network analysis framework that summarizes network traffic into log files containing metadata. It offers packet capture, traffic inspection, intrusion detection, log recording, and its own scripting languages. These scripting languages allow Malcolm developers to extend Zeek's functionality through plugins. Suricata is a signature-based network detection engine. Users can utilize built-in Suricata rules within Malcolm or create custom rules to detect specific patterns or signatures indicating network compromise. Arkime is a large-scale, open-source index full packet capture and search tool. It stores network traffic in PCAP format and provides optimized indexed access for searching and analyzing traffic. Arkime enables users to view the raw packet capture data associated with session metadata. Using Zeek, Suricata, and Arkime together allows us to understand the bigger picture of network data. It's similar to the parable of the blind people and the elephant. One person feels the tail and thinks it's a rope, another touches the body and thinks it's a wall, and a third grabs the trunk and believes it's a snake. Individually, they don't see the whole picture. It takes multiple perspectives to understand the entire elephant. Malcolm combines these tools to help analysts see the entire elephant. By leveraging the strengths of Zeek, Suricata, and Arkime, Malcolm provides a comprehensive view of network activity.
To correlate data among these sources, Malcolm uses four key fields: Event.provider, Event.dataset, Event.id, and Network Community ID. First, Event.provider is the data source. This includes Zeek, Arkime, and Suricata. Next, Event.dataset is the log type within the provider. For Zeek, it varies. Zeek has logs such as con or connection logs, HTTP logs, notice logs, software logs, and more. For Suricata, it is always alert. For Arkime, it is always session. This distinction is necessary because Zeek generates multiple log types, while Suricata and Arkime each generate only one log type. Next, Event.id is a unique identifier for the session or observed event. This field is set for Zeek and Suricata logs, but not Arkime sessions. Event.id helps Malcolm correlate transactions within a provider by linking related events within the same session. For instance, if you do a web search for Goofy Cats, the Event.id would group together all actions as part of that session, including viewing the web page, selecting a cat picture, and downloading it. Event.id's usefulness is as a link within a single data source. For example, there is Zeek's con log or connection log, HTTP log, the HTTP request and response, and files log, Zeek's record of the download of the cat picture. These are all linked by the common unique identifier stored in Event.id. Last, network.community_ID is the field that bridges data across different data sources. It ties Zeek, Arkime, and Suricata together using a widely implemented flow hashing standard, ensuring reproducibility across various tools, both within and outside the Malcolm ecosystem. Throughout this video tutorial, these fields will act as a foundation for pivoting between data sources.
2. Scenario demonstration. Fitting it all together, let's explore how to pivot between data sources to get a comprehensive view of network activity. Welcome to Snowpoint Corp. Susan, the system admin, has noticed an uptick in phishing emails to employees and wants to use Malcolm to investigate. She begins her investigation with dashboards, setting the data search timeframe to the afternoon of May 4th. Setting the timeframe is crucial for any Malcolm analysis as it determines the data visible for analysis. From the Malcolm Overview dashboard, she sees different protocols during the search timeframe observed by Zeek and Suricata. Note that OpenSearch Dashboards is a front-end visualization tool for Zeek logs and Suricata alerts, but not Arkime sessions. She will pivot to Arkime later to examine the full PCAP. In the dashboards, she can narrow her focus to one data source by clicking on the Zeek log to apply a filter. Notice the field we discussed earlier, Event.provider. This filter shows only Zeek data. To clear the filter, she clicks the X. The second field we discussed earlier, Event.dataset, is displayed in the log type table. The first column is data source, Event.provider, and the second column is log type, Event.dataset. By default, this table is grouped by data source and sorted by event count, descending. The most common Zeek logs appear at the top, followed by Suricata logs. Hovering over a log entry reveals plus and minus icons to create filters. Clicking the plus arrow next to Suricata applies the filter Event.provider Suricata. Clicking the plus arrow next to the log type applies the filter Event.dataset alert. To clear the filter, she clicks the X. To focus on email, she applies a filter for the Simple Mail Transfer Protocol, SMTP, by clicking the plus next to that log type, resulting in Event.dataset, SMTP. Notice that only Zeek data appears. This is because Zeek has unique log types, while all Suricata logs are alert. Even if Suricata captured SMTP logs, they wouldn't appear here due to the Event.dataset, SMTP filter, which is unique to Zeek. To get both Zeek and Suricata logs for SMTP, she needs to use the application protocol table and filter by protocol. Comparing the two, the Zeek data source shows 22 logs for SMTP in the log types table, while the SMTP protocol in the application protocol table shows 91. This indicates additional sources contributing to the count beyond Zeek. This illustrates why it's crucial to have a basic understanding of what the fields comprising Malcolm network logs represent. Malcolm's powerful searching and filtering capabilities help you narrow your search, but without understanding a field's meaning as you filter for it, your search results may not contain the data you intend to analyze. Returning to the scenario, Susan knows she has phishing emails and has identified SMTP traffic in both Zeek and Suricata logs. She can investigate further by clicking on the SMTP dashboard under Common Protocols. From the SMTP dashboard, she sees that the SMTP traffic is not encrypted, as shown by the false entries under the TLS table. TLS, Transport Layer Security, is a cryptographic protocol for secure communication over a network. Susan also notes that the emails are internal since there's no country specified, indicating they are being sent and received on an internal email server. Browsing through the 22 SMTP emails, she examines the subject lines. Most look normal, like morning report from field station A. However, some subject lines raise concern, such as weird email received, which could indicate a reported phishing email. The most suspicious ones are account expiration. Please open immediately. An annual report attached. Do not miss. Notice the multiple exclamation marks. These emails convey a sense of urgency and unprofessional tone, typical of phishing attempts. To investigate further, Susan applies a filter by clicking the plus next to the suspicious email. She can now see the sender and recipient email addresses, both internal as well as the source and destination IP addresses and the subject and size of the emails. However, this information reiterates what she already knows, and she needs more details beyond those contained in this log.
This is where pivoting comes into play. Susan turns her attention to the Event.id field, which links logs within one data source and allows her to view all logs related to a single event or session. Towards the bottom of almost every dashboard, there is a table with a line-by-line, event-by-event view of the data. She looks for the column labeled Event.id and adds a filter for the event ID associated with the email she's investigating. After applying the filter, She scrolls to the top to see her filters in the filter bar. She's now filtering by the subject, account expiration, please open immediately, and the event ID unique to that email. Applying filters is often called drilling down because it narrows the focus. Next, she removes some of the filters she'd applied previously, which is called pivoting, because she's shifting her focus to explore one of the filtered items. The filter is still narrowing the results set to a single aspect of the traffic she's exploring, but she's now expanding the search to see what else applies to that filter. Next, she pins the Event ID filter across all apps. This is a crucial step because it ensures the filter remains in place, even when she leaves this page. With this filter applied and pinned, she's ready to pivot to other dashboards to view other logs associated with this event. She clicks on Overview to return to the Overview dashboard to see what other Zeek log types are related to that event ID. Now she sees that not only was there an SMTP log associated with the event, but also connection and files logs. These were all part of the same email, but different aspects of it from Zeek's point of view. She wants to learn more about the file that was sent. With the event ID already filtered and pinned, she clicks on the files dashboard to see the type of file sent in the email. It was a text plain file type and was only 182 bytes. If needed, she could download this text file to see its contents. So far, Susan has gathered significant information about the potential phishing email by drilling down, pinning the event ID, and pivoting to learn more. However, she has only explored Zeek as a data source. She now wants to check if Suricata or Arkime have additional information about the session. The event ID is specific to Zeek and provides internal linkage within that data source. To expand her search to other data sources, she needs the Community ID field. Community ID is a fingerprinting algorithm that helps identify network connections, which are sometimes also referred to as flows or hashes. The Zeek connection log is crucial for pivoting to other data sources, serving as a bridge between Zeek and Suricata or Arkime. She scrolls to the con log. She expands the con log field and finds Community ID. She then clicks Filter for value. This narrows the focus. At the top of her dashboard, it's now filtered by Event ID and Network Community ID. She selects Pin All from the filter dropdown to prepare for pivoting. Having drilled down by applying filters, she now pivots by removing old filters to see additional data. She'll remove the Event ID filter. To do so, she can either click on the X to clear it totally, or she can simply disable it by clicking the tag and selecting Temporarily Disable. Now she sees a Suricata event tied to the same session. She has successfully pivoted from Zeek to Suricata using the Community ID as a filter. Knowing there's a Suricata alert associated with this Community ID, she navigates to the Suricata dashboard for further investigation.
So what about Arkime? Once Susan finishes examining this email, she may wonder if there are any other emails with file transfers. She clears her filters to start fresh and approaches the search from a different angle. Through a process of drilling down and pivoting, she finds that the email, Annual Report Attached, Do Not Miss, contained a word attachment which triggered an antivirus signature. She wants to know more about the antivirus signature, so she moves to the signatures dashboard. There she finds that ClamAV detected .dropper.valeria. Up to now, her investigation has been within Zeek. To see what other data sources can tell her about this file, she scrolls down to the con log. Rather than clicking on the filter options, she clicks on the event ID value, opening it in Arkime. Arkime examines all three data sources, Zeek, Suricata, and Arkime sessions. While Arkime has a different interface, the techniques for pivoting among data sources remain the same. Susan begins by expanding the search timeframe. Initially, the results include only Zeek logs because she's filtering by a Zeek-specific event ID. To see other data sources, she goes to the con log, expands it, and applies a filter for Community ID. Arkime uses Boolean logic in its search queries, so she selects OR to include all the Zeek logs, as well as logs from other data sources, Community ID. Now she sees the Zeek logs and Suricata alert from earlier, plus an Arkime session associated with that file. She clicks the plus for the Arkime session to expand its details. Now she sees not only the header information, but also information about the raw email itself, including its content.
For analysts, the pivoting process is one of the most powerful workflows in Malcolm for gaining insights into network communications. Start by applying filters to drill down on items of interest. Pin a filter, then pivot to learn more. There is much to be gained by starting broad, narrowing the search, and then pivoting to other data sources for deeper insights. That concludes the demonstration of how to pivot between data sources. Check out the description section for links to the Malcolm GitHub site, a Malcolm discussion forum, and more.